Morning. This is Mike Krenke, the Program Director for the Sustainable Forest Education Cooperative out of Cloquet, Minnesota. Welcome. Today we have Ann Pierce, who is the head of the State Natural Areas Program for the Department of Natural Resources in Minnesota. This will be a very interesting program. Ann's going to talk about the State Natural Area Program and then how it relates to potential climate change in state natural areas and how it relates to climate change. So I'm going to do a little bit of introduction here first, just a couple logistics, then I'll talk a little bit more about the program today and then introduce Ann Pierce. So for logistics, you see on your screen on the upper left-hand corner is a chat pod. Right below Ann's photograph, farther down, there's a space that is a chat pod. You can click on that chat pod and then click on the right little icon there, which looks like a little brain, and that will bring up your question. So if you would like to ask any questions throughout Ann's presentation and towards the end, just feel free to type in that chat pod, and then it'll come up on screen and Ann can answer your question. If you would like continuing forestry education credits as a stewardship plan writer, just indicate that. Usually after your name is how we do it, but we will make sure that you get stewardship plan writer credits within the tracking system that we do for the DNR. So the program today will be about an hour long. Ann's presentation will be about 45 minutes, and we'll have questions and answers. And Ann's PowerPoint presentation will be archived on the site. So if you go to the SFEC homepage on the upper left-hand side, you'll see webinars. You click on webinars, and you can find the link for this particular webinar and all the other ones that we've hosted. So it's a good chance to review the materials, or for others that have not had an opportunity to view Ann's webinar, to view it later on. You can refer people to the SFEC website. So today we're talking about Scientific and Natural Area Program and Managing for Climate Change. The Scientific and Natural Areas Program was established in 1969 by the Minnesota Legislature. The program currently administers over 140 natural areas. The SNAs are found across Minnesota's landscape, and the program's long-range goal is to protect at least 5 locations of plant communities known to occur in each landscape region, and 3 locations per region of each rare species, plant, or animal and geological feature. And we'll talk more about the specifics of the State Natural Areas Program. Ann is currently the overseer of the Conservation Management and Rare Resources Unit at the Minnesota DNR, which includes Natural Heritage and Non-Game Research Program, State Wildlife Action Plan Program, Forest, Prairie, and Wetland Policy Working Group, and the Scientific and Natural Areas Program. Ann has also worked as a terrestrial invasive species coordinator with the Invasive Species Unit and a regional plant ecologist with Minnesota Natural Heritage and Non-Game Research Program, collecting, managing, analyzing, and interpreting information about native plants, plant communities, and non-game animals. Ann received her master's from the University of Wisconsin-Stevens Point in forest ecology and focused on restoration ecology. She received her PhD from the University of Minnesota in conservation biology. I'd like to introduce Ann, and thank you very much for the program today.
Thank you, Mike. Just to give everybody a heads up, this is the first time I've actually run a PowerPoint on a webinar, so if I stumble a bit, sorry about that. Participated in webinars, but haven't actually run the PowerPoint on it. So I think I know most of the people that are participating today, but what I thought I would do is just give a general overview of the program first, the program as a whole, and then kind of that'll give a little bit of background about how we can think about the Scientific and Natural Area Program and managing for climate change into the future. So with that, I'm going to just kind of dive right into what the program components are, and Mike did a nice job of giving an overview of what the goals of the program are. In general, the program was set up to protect and manage special places and their rare features, and that not only includes biological features but also geological features. And there's kind of two major components of the program. There's the designated state scientific and natural areas, and there is the Prairie Stewardship Program. And, whoops, I'm sorry, a little bit too fast. Depending on which part of the state you're in, you're probably more familiar with one than the other, but both of those are part of the Scientific and Natural Areas Program. Just really briefly, it looks like most of the people that are listening in are from the kind of forested area of the state, so I'll give you a little brief overview of what the Prairie Stewardship Program is about. Basically, that program was established to balance the social and economic needs of private prairie landowners with the conservation of the state's native prairie, providing information for land use decision makers, for protecting and restoring prairie ecosystems, and for promoting preservation of that rare resource. So if you think about our prairie landscape, which most of it is in the western part of the state and this kind of heads off to the south, there's very little of that left, and most of it is actually in private land ownership. So this was a program set up to kind of steward that resource throughout the state. Just a couple examples of these are, the pictures I have are all pictures from either prairie bank easements or scientific and natural areas, but areas that we are investing in and helping to maintain and restore in certain circumstances. So some of the unique things that we might be looking at are kind of these crystalline bedrock outcrops, which is not only a geological feature but also a ecological feature. Kind of a combination of both, and find a lot of rare resources in those ecosystems, from the Dakota skipper to the showy milkweed. And of course, in the southeast, we're looking at areas where we're actually protecting some habitat through easements for timber rattlesnakes. And we have quite a large program actually looking at working with private landowners to help enhance habitat for that species. Other parts of the Prairie Stewardship Program include the Prairie Tax Exempt Program, which exempts native prairie land from property taxes. And the eligibility requirements are kind of listed below. It basically has to have never been plowed, it's not currently being used as pasture, has limited tree cover on it, and is at least 5 acres. And then it must also be prairie vegetation dominated, which is to say that there's going to be some brome grass in those areas. This provides tax exempt year to year and is not necessarily a legal protection. There's also planning assistance and working with private landowners to help with technical assistance on native prairie areas. And then education, workshop materials, and things like that. And the kind of legal protection component of that Prairie Stewardship Program is the Native Prairie Bank easement. So that was created in 1987 by the state legislature. Landowners receive a one-time payment for preserving their prairie while it remains in private ownership. And they can negotiate to maintain certain rights on those easements, from grazing to seed harvest to haying, depending on what the situation is. And these are usually permanent easements. Of course, those are the priority for this program. That protection program, we have over 8,000 acres in that, over 100 easements as of 2010. And this represents about 3% of all the prairies left in Minnesota. So there's probably only about, of the original extent of prairie, there's probably only less than 0.1%, and this represents about 3% of that. The other major part of the Scientific and Natural Areas program are the scientific and natural areas. And of course, prairies are placed under protection through easements, but also through our scientific and natural areas through acquisition. So they have kind of two forms of the ways that they can be permanently protected. And then our forested areas really fall under the scientific and natural areas portion of the program. And the goal of the scientific and natural areas portion of the program is to protect and perpetuate in an undisturbed natural state those natural features which possess exceptional education or scientific value. And so some of the focus in this system is to look at areas that have an extent of rare resources on them, high quality native plant communities, which means that they haven't been disturbed, that they don't have a lot of invasive species on them, things like that, and geological features of state significance. So one example of the geological features is where we just recently purchased Chimney Rock near the Twin Cities. And another example would be a cave down in southeastern Minnesota, which actually has part of the river running through it. So that is part of a scientific and natural area, strictly because of its geological feature. And so basically, these areas are designated by the commissioner as units of the state outdoor recreational system, just like parks and things like that are. Their designation is focused on research, education, and public use. So typically public use in this instance is bird watching, hiking, things like that, but we also have areas, a number of areas that are actually open to hunting. Anything that can be allowed on these sites without harm to the feature for which that site was purchased. And under this type of acquisition program, like Mike had mentioned, the goals are to have 5 locations of each native plant community that occurs within that landscape, and we're looking at landscapes as the subsection, and 3 locations per landscape of each species that occurs within that subsection or geological feature. We have not met those goals yet, but those are the long-range goals for the program. And just to see what we have so far, we have over 180,000 acres on 152 SNAs. Now about 146,000 of those acres are actually peatland SNAs, which are obviously up in the kind of central northwestern part of the state. But a huge section of those are the peatland SNAs. The key focus of scientific and natural areas is to allow for what we focus on in our management is ecological management. There are areas where monitoring and research is undertaken, outreach and education, and then the other part of this program is land acquisition and designation of the SNAs. So this is just a map showing each kind of section of or province of the state and the number of SNAs we have in each area. So as you can see, and this will get into why these will become important for the kind of climate change management, as you can see, they spread out throughout the state. So they cover a broad area and probably represent a lot of different types of plant communities that we have in the state. So with that overview, and I kind of went through that kind of quickly, but I think many of you are probably familiar with it. So with that overview, I'm going to step into the kind of how we can use these scientific and natural areas to help us manage and adapt to climate change as we move forward. So I'm just going to talk a little bit about what some of the predictions are for the state, talk a little bit about what people are thinking will happen in certain in certain areas of the state and certain types of habitat of the state, and then talk about how we manage SNAs and how we use SNAs can actually help us into the future in adapting to climate change. So just a couple things that the predictions are for Minnesota, that we will have increased lows, and as you can see, as you move north, those increases in the low temperature in the state go up. And that is probably the biggest driver in some of the changes that we're going to see. It's not necessarily that the highs are going to be 1.2 degrees Fahrenheit higher, but the lows are going to be 3 degrees higher. And on an average, you can see it kind of, as you go from south to north, it gets higher changes in temperature. There has been some work done for the state, and I'm taking this from Galadowitz et al. 2009, which was published in Conservation Biology, if you're interested in looking at that article. Basically what they did was they took the climate projection models that were developed by the IPCC, and they did what's called downscaling them. So those are based on large grids. They downscaled those grids to smaller grids to represent a region of the country, which Minnesota was kind of at the center of that region. Then they took projections from 2060 to 2069, and they put those on a base map of annual precipitation and temperature from 1961 to 1990 to kind of show what we have right now and what the projected changes are going to be and what our landscape, at least from a climate perspective, might look like. So if you look at the darker gray, that is what we currently are experiencing. The lighter gray is what the climate is projected to change to. So for instance, northeastern Minnesota is going to look something more like kind of the south central part of the state with precipitation and temperature. And the temperature intervals that they're looking at are a change in about 2.8 degrees Celsius or 5 degrees Fahrenheit. Precipitation is about 12.7 or centimeters per year. Now these projections, the precipitation aspect of them is much more uncertain than the temperature aspect, and that gets us into kind of having to rely on a little bit of uncertainty to think about our management into the future. So one of the predictions actually for various parts of the state is that we will possibly see increases in temperature. This is actually showing us the changes in, I'm sorry, not temperature, precipitation. This is showing us the changes in precipitation from 1891 to 2009, and as you can see, the southeast has experienced more precipitation. But if you get into these pockets, especially in the western part of the state and some areas of the northeast, they're seeing decreases. And that's kind of what the predictions across for the future are also, that there's some variability, but the other piece of uncertainty with that is that precipitation may not fall as it historically has, which is throughout the summer and kind of relatively small storm events. It may become more extreme. So we have extreme events like we've seen in the southeast where we had 17 inches of rain in 24 hours. So that is another uncertainty surrounding precipitation. A couple other predictions that people are making for Minnesota. We, of course, are sitting on a transition zone between the prairie forest border, and because of changing warmer temperatures and changes in precipitation, and this might not be, we may see higher inches per year, but if it falls in big storm events, the availability of moisture is not going to be the same. It's going to be reduced. So with that, they're predicting the chances of that prairie forest border, or the climate that is driving that prairie forest border, to shift to about 300 miles to the northeast. Now keep in mind, this is not to say that all that vegetation is just going to follow it as is. So there's going to be some changes in that, and I'll get to that in a minute. Other things that people are thinking about and possibly seeing already is that there are some changes in phenological response. So different species respond differently phenologically to some of these changes in temperature and moisture. There's variation among species, and this potentially could result in phenological mismatches. So one example would be if the Karner blue butterfly hatches early before the lupin comes out, it will not have its nectar source. Another example that they're actually seeing is that the food supply for the pied flycatcher nestlings peaks before the flycatchers arrive to lay their eggs. So the nestlings are not having a food source when they hatch, which of course can cause kind of a circular response to one thing changes, another thing actually is diminished because of that change in something it's dependent on. So that's another concern. So these are some things that people have been thinking about and predicting for this area of the country and Minnesota in some circumstances specifically. I just wanted to go into kind of what, from a habitat standpoint, what people are thinking about when they're thinking about changes in certain habitats. So the first one I wanted to start out with was wetland systems. And as I go through this, I'm going to show you some of our either prairie bank easements, again, that are protected through easements, perpetual easements, or our scientific and natural areas that are protected through acquisition, and examples of these types of communities that we have in protection. And of course, we have other examples of these communities in wildlife lands, forestry lands, state parks, and all sorts of other areas. But these are just some examples of ours. So Minnesota contains a variety of different wetlands, from the peatlands, calcareous fens, which are actually a form of peatland. The quote-unquote typical peatlands are the acidic peatlands, and the calcareous fens are they have more of a basic pH. And then we have floodplain forests, prairie potholes, and your typical wetland system. Overall, the general impact is that these areas will probably have decreases in moisture, and because of that, potentially increases in invasive species. Some of these areas, of course, are experiencing quite a bit of invasive species already. The peatland system, remember, for the scientific and natural areas, most of our acreage is actually owned in these peatland systems. And the Minnesota peatland systems are globally important system. In fact, they're being proposed to be identified as globally important. And one of the important things that they do, especially in the face of climate change, is that they store carbon. And they occupy about 3% of the Earth's surface, but they contain about a third of the total soil carbon pool. And we have about 7 to 8 million acres in Minnesota. Changes in temperature and moisture in this circumstance could result in increased plant or changes in plant composition and productivity, and changes in the evapotranspiration, which would result in an increased decomposition rate, possibly increasing the pH of the site, also increasing the oxygen in the site, and really opening up these sites for invasive species and reducing their ability to store carbon. Another prairie system that's important to the state, of course, is the prairie pothole region, and declines in soil moisture. They're predicting to see fewer wetland systems, shorter hydro periods. Sorry, I forgot the D in hydro periods. Increased variation and the extent of surface water, and changes in the depth of salinity, temperatures, changes in temperatures in plant communities. And there was a study done by USDA that looked at where the shift in the prairie pothole region might occur. And as you can see from this map, it's showing that the shift in the kind of optimal wetland conditions is going to shift to the southeast. And if you think about what is in Minnesota in that area, it's mostly agricultural lands, and there's a lot of drained areas, so there's not a lot of opportunity for wetland systems in that area right now, currently as it is. So that's a concern for that area. And these are some examples of wetland systems that we have in the state. So this is a wet meadow, sedge meadow system in northern part of the state. This is actually near the Twin Cities. This is Seminary Fen, a fen system which is, of course, has peat in it. And one of the things to notice, you see the red is where the Seminary Fen Scientific and Natural Area is. And there's other public land ownership around that, which actually, because of climate change, could be very helpful. So fens are fed by groundwater. One of the things people are worried about with groundwater is that we will have a decrease in infiltration and feeding of the groundwater, but we'll also have an increase because of population in withdrawal. So the fact that this watershed of this fen is in public ownership is very useful for its future in the face of climate change. These are just some of the features that Seminary Fen was purchased for the protection, of course, the fen itself, calcareous fen. And one of the key features of a calcareous fen is one of the rare plants, sterile sedge. And then, of course, small white lady slipper and yellow lady slipper are some of the key features in that system. So now I'm going to move on to the prairie system. And again, this is a really broad kind of overview of these systems. And I'll talk a little bit about what site differences might play in the response of these systems to climate change. But overall, we have a very fragmented prairie system. As you can see from this map, the red represents remaining native prairie within the state of Minnesota. And some of the signs that we're already seeing in these prairie systems, at Blue Stem Prairie in western Minnesota, we're seeing past flowers bloom 2 weeks earlier. There was a study done looking at 20 migratory bird species in the northern prairie region, and it indicated that there were shifts in 18 of these migratory species to earlier migration dates. One of the key features in this landscape and its response to climate change is going to be connectivity. Connectivity is probably a bigger barrier to adaptation in this landscape than anything else will be, even the results of climate change. Some of the predicted issues in the prairie landscape are that those mesic prairies that we have are going to diminish because of diminishing moisture availability, and the drier sites will probably increase, but that will only happen if there is connection for migration of species from site to site. Other things that we're seeing, we've seen a decline in the prairie fringed orchid from the southern portion of its range, kind of as if it is moving to the northern, migrating north. And we also know that the response of this species to certain stressors like drought is that it reduces its flowering and it increases the mortality. So those kind of things that are predicted to come along with climate change are going to be an issue for some of the rare species that we find in this system. And again, these are just some examples of some of those prairie systems. Now, if you look at this one, this is a dry sand gravel prairie, and the predictions are that this probably won't, from climate change itself, won't be too stressed because it's going to be drier, which this is adapted to. One of the issues, though, for this site is going to be invasive species. So the response of those other stressors to climate change could impact even a system that would be relatively resilient to climate change itself. In this site, there's 13 rare species. That's the reason that this site was purchased, and this is just a list of some of those. This is Butternut Valley Prairie, and this is a mesic prairie. And because of the prediction in decreased soil moisture availability, this area probably will experience some changes. And as you can see from that map, it's pretty much out there on its own in a matrix of agriculture. So it's not going to have a lot of buffering to that impact of climate change and reduction in soil moisture. And then the forested system. So for the forested system, remember I mentioned that there's a prediction that that prairie forest border will move to the northeast, and that's the climatic conditions. And we know that we see forests historically where there is adequate moisture and where they have been protected from fires. And it's kind of a multi-pronged reason why we have forests in our landscape, but it has to do with climate, physiography, nutrient levels, and disturbance. So as that climate changes, it's going to change our forested system, and what that looks like is relatively unknown at this point. But we do know that those conditions, that climatic signature of prairie forest border is going to shift, and our species are probably going to be sensitive to that. Right now we have over 107 different forests and woodland native plant communities in Minnesota. So they're probably, some of them are going to respond very differently than others. In general, forest systems are expected to be vulnerable to climate change. And in Minnesota, we're particularly vulnerable because of where we sit in that landscape, that transition zone between warm, dry, moist, humid transition area, that climatic zone. This is just an example from Reich, Peter Reich's work there. He's looking at boreal systems. And if you look at, this is our latitudinal band in northeastern Minnesota, and you can kind of see where the species are that are either on the northern end of their range or the southern end of their range. And the prediction is that some of those southern end of their range species are going to be moving out of our area. They're going to be moving north. Some of the southern, the ones that are on their northern end of the range, will probably become more prevalent. So the thought is that we are seeing some increases in oak and maple dominance in our forest communities in some of the conditions right now. We're probably going to continue to see that in the warmer future, and this would represent a shift from that boreal system. But the issue is that both our northern and temperate tree species may not perform to their highest potential in that changing climate. So that is to say that even some of these temperate species might be stressed, and they might be outcompeted by other non-native species and things like that. So we really have to think about how we are managing through that transition in some of these forested systems. We're already seeing some impacts. So we've seen that northern tree species in the eastern and central part of the U.S. are migrating north about 6 miles per year. About 84% of the resident forest birds in the U.S. have shifted their winter range, about 75 miles. We've seen an increase in mortality in tamarack trees because of eastern larch beetle, and this is likely to increase as those trees become more stressed from climate change. And then, of course, didn't feel like it this year, but we are seeing shorter winters and less availability of that hard freeze for us to go in and do some of the logging operations that are critical to have a hard frost for that. What the concerns are for that accelerated climate change, that we will see more frequent droughts and floods. We'll have more frequent natural disturbance events like fires because of the drought, blowdowns because of the extreme weather conditions, and potentially ice storms. All of this coupled with increases in insect outbreaks and invasive species could increase the tree mortality. So the thought is that even though we're seeing, the tree species are a long-lived species, so you might see some changes in the understory in response to climate, like regeneration of temperate species as opposed to boreal species, but you wouldn't see that change in the canopy unless you're having some of these other stressors. increase. We've also seen changes. There's been a long-term study at Leopold's Farm where they're analyzing 61 years of data, and they've seen results that show that cardinals are singing 22 days earlier, forest phlox is blooming about 15 days earlier, and butterfly weed about 18 days earlier. So these are just some examples of S&A areas that are within forested ecosystems, and this is an iron-rich seepage blend or seepage area in a floodplain system, and of course this is going to be sensitive to less moisture and things like that. This is Lester Lake. It has some unique species in it that need that moisture regime to flourish. The sedge meadow. And then we have some special areas like, this is Clinton Falls in southeastern Minnesota. It has the largest population of dwarf trout lily, which is a federally endangered species. It's endemic to only 3 counties in Minnesota, occurs nowhere else in the world. What's going to happen to this species with climate change? It's really hard to know, but it's already being stressed because of land use changes. So as these rivers become flashier, the species is often lost. Whole populations can be lost. So this is just the area where it's found in this S&A. So one of the things that as managers we need to think about are those interplays between the existing threats we're already dealing with, like invasive species. This is a blowdown. This is the blowdown area that experienced a blowdown and then a fire. And added to that, we're going to have another stressor of climate change. And so how do we manage for that into the future? One of the things the S&As can play a role in this is, I think, a number of things. One thing is that we manage these for resilient systems. So it's not to say that these sites are not going to change, their species composition isn't going to change, things like that, but these are, the sole purpose of these is to continue the ecological values. They're going to be managed in a resilient fashion, and hopefully we can respond to those changes relatively quickly. Other areas have, of course, other priorities that have to be mixed in with some of these things. And so this will be an area where maybe we can see what's happening with climate change with kind of without other impacts on it. So what, are invasives moving in regardless of our management because they're responding to climate change? Are the understory species starting to change regardless of management because of climate change? Those types of things. But we still need to manage these systems. And some of the things that are going to become increasingly challenging are how to manage these systems for, is fire going to continue to be able to be prescribed in these areas? Are they going to change their regime so much that it's not going to be feasible anymore? Is it going to be able to help us deal with invasive species as it has been in some instances? Right now we use fire quite a bit, especially for the native prairie bank areas and the S&As that are prairies. So we've done over 4,000 acres of prescribed burns. And it's a big management tool, but we're also going to face increases in other existing stressors. Like we already have areas where deer are having a great impact with climate change. Deer can respond pretty well to almost any condition. Most likely they're not going to have an issue with climate change, so we're probably going to see more impacts of those. And so we're trying to figure out, how can we protect some of those really, really sensitive areas from some of these impacts. And of course, this is not going to be logistically feasible in very many areas, but this is an area where we have hemlock, one of the only areas that occurs in the state, and so we're going to do quite a bit of effort to try to manage for those. The other stressor that we're already facing and dealing with quite a bit, especially in the southeast and the central part of the state, and it is becoming a bigger issue in the northern part of the state, are invasive species. So with increases in disturbance of drought, invasive species are going to be able to have more opportunities to move into stress communities than maybe they had before. If our peatlands start to dry out, start to change their characteristics, potentially they will be more susceptible to invasive species also. So one of the things that, of course, we're trying to continue to do is to restore areas that could act as buffers to more high-quality areas. So in this example, we're using the site itself to come up with seeds to help in the restoration process of that whole site to help protect the other features in the S&A. The next kind of ideas for how S&As can help us manage in the face of climate change kind of come down to using S&As as a monitoring site and planning for climate change into the future. So one of the things that I think is going to become more and more important is the idea of connectivity and using kind of the building blocks that we have in the landscape right now to help us reconstruct and restore some of those systems to a more natural state. So a pasture increase, if it had been prairie in the area, increase the prairie species in that area by using the neighboring site to help collect seeds and things like that. One of the specified uses for scientific and natural areas, of course, is science and education. And so these sites can be and should be used as a monitoring and research area for, number one, determining are we seeing changes in climate, in species composition because of climate change? Are we seeing increases in invasive species? Are we seeing reduction in certain species germinating and others increasing? It can be kind of the canary in the coal mine if we can establish some monitoring sites in those scientific and natural areas. And that can provide information to other land managers as to what we're seeing happening. The other thing I think these can also be used for is research. So some of the questions, well, is it really climate change that's causing this to occur, or is it some management strategy we've been using? These areas can help us answer some of those questions to be used as controls or whatever the case may be. So I think they'll play a really critical role in that monitoring and research aspect of helping us manage for climate change. Currently, we have over this year, or last year, we issued over 33 permits to do research. And we have developed a program where we're doing accelerated prairie monitoring, which is basically a status and trends monitoring on prairies across the state. And these include scientific and natural areas, federal owned property, and state wildlife areas also. So a variety of different types of areas. Again, I think for us to think about planning into the future, we need to figure out these are the systems we have right now. Where are the gaps? What communities are we missing in this system that we may want to identify and try to include in the system? And so to identify those areas where we might want to do some purchasing or doing some rebuilding, connecting areas to one another. The idea of connectivity is going to become more and more important. And one of the things we have started to do is looking at planning on a landscape level. So taking our long-range plan of 5 and 3 and making a more exerted effort to look at where the connections should come into play here. How can we connect these systems? We've also done some work as a department looking at the prairie landscape and how to connect the existing native prairie with maybe some different type of land use. So connectivity is going to become more and more important. And then I think also getting on to the ground and trying to figure out how to best manage the systems that we have for this type of changes that we're seeing. So one of the things that we're looking at, again, in the prairie landscape is that landscape level planning where we're going to be doing a variety of different types of land use on areas that we have protected in some way or are working with landowners on. So there might be an SNA in an area, and connected to that is a landowner who's doing rotational grazing or perennial cropping with haying. That is going to be beneficial to that SNA because it's a more stable type of system than, say, a row crop would be, and it's probably going to allow for some buffering of the high-quality system in response to climate change. So also we have to think of new ways of dealing with some of the issues that we have. One example is down in southeastern Minnesota, we're using goats on some bluff prairies because they're so overtaken by buckthorn that we really can't effectively get into them cost effectively. And we're trying to use goats, and we actually got this idea from Wisconsin, which is using it on their natural area system to see if it'll be effective in controlling invasive species. Another aspect of our program is the outreach and education, so we can kind of start to help bring the message of climate change, the impacts climate change is having, along with the other stressors on the landscape, to the public and to legislatures and things like that. This is just a stewardship day out at one of our SNAs, and of course they have a big thistle in their hands. And another example is we had a Friends of the Mississippi River Volunteer Knapweed Pull Day out at Pine Bend Bluff. So just getting people out there to help them understand what the issues are facing our natural resources is going to be important. And then I think to keep in mind some of the net effects of this climate change will be shifts in species range, and this could result in reduction of economic species of value, like timber and, ducks for recreation and things like that. Warming combined with changes in precipitation is going to shift that prairie forest border. Again, it's going to cause disruption to ecosystems, recreational changes, and changes in industries that we're dependent on. And those ecosystem reductions probably won't be that prairie marching northeast. It'll probably be some novel system that we haven't necessarily seen before, and hopefully not monocultures of invasive species. So this becomes a real challenge for our resource managers, and I think one of the things the Scientific and Natural Areas program can do is try to help answer some of the questions that we have, be kind of the canary in the coal mine for changes that we're seeing on the ground, and really help maintain some resilient, focus on maintaining some resilient systems or resiliency into those systems on the landscape. So with that, are there any questions? Okay, so Mike has asked that mention the migratory birds are migrating approximately 75 miles further north, and trees are migrating approximately 6 miles. Basically, what they're seeing, okay, so on the northern edge of the tree species ranges, what they have been doing long term is kind of, the Forest Service has been doing some of this, monitoring, where they're seeing species move their northern range, and what they have found is that they are seeing about a 6-mile shift per year of some of the species shifting their northernmost range upward. Not to necessarily say that that southern range have they seen those shifts yet, but they are seeing that northernmost range. So from the plots that the Forest Service has, they're recording all this data year after year. They've been able to measure that. The 75-mile farther north of the migratory birds, of course, basically those are there's a variety of different bird counts, and some of those are based on researchers doing that, some are volunteers, but they have noted that there has been a 75-mile shift north, which is not to say that that's still within a forested area. So it might be that for example, the species northern end of its range was northern Minnesota, and now they're seeing it up in Canada. So it's still within that forested area, but it's just shifting it 75 miles north within that same kind of landscape. But it does point out that some things are shifting faster than others, or further distance than others. Okay, well, if there aren't any other questions, of course, if you want to get a hold of me, you can certainly email me, and there are going to be some, a framework. I'm reading what you just wrote, Mike. Just a second.
Okay. Can you hear me, Ken?
I can hear you, yeah.
Okay.
Yes, I would be, yeah.
Okay. We have a couple professors that are thinking about developing a workshop on adaptive management with climate change considerations for this next year. Tony D'Amato, the Fralake are two of those.
That'd be great.
Yeah, we'll be getting back to you once we start talking about it more. I see Paul has a question as well.
Okay, I'm going to read your question, Paul. Personal observation, tamarack appears to be outcompeting black spruce on many of our forested peatlands. Curious about what that means with respect to larch beetle outbreaks. And so, and I didn't get back into this, Paul, but the idea that, you know, some of the things that I was saying are across a broad landscape, and there are going to be some site-specific differences. So, for instance, if you're in say a bluffland area and it really has steep ravines around it, the impact of climate change might not be as impactful. So it could be that in this case, you know, if you have pockets of tamarack that are occurring and they're distant from the larger populations of the tamarack, they may not be as susceptible to the larch beetle. They may be better able to withstand the attack if they are in an area where the conditions are not being as highly impacted by climate change. But the concern is, I think that, you know, not only with the larch beetle, but with emerald ash borer, as we have systems that are dominated by one species and these insect outbreaks move through and the trees are already stressed in some way, are we going to have, you know, kind of a systematic die-off of a canopy, especially in an area that has a lot of moisture, and then the result could be a real shift in that community. It could result in changes in the water levels. It could result in increases in invasive species because that is the thing that can grow the fastest and respond the quickest. So I think those things are concerns, and they may be more or less of a concern depending on the landscape context of where it's happening, type thing. So eastern white cedar, you know, I think there's a number of issues with eastern white cedar. Of course, there's the deer issue, which will continue to be an issue, probably to escalate potentially. And then there's the issue of what happens to those systems that it's in, so the wet systems that it's in, if they start to dry out, that's going to be another issue for the eastern white cedar. The other issue, of course, will be the climatic changes, the temperature changes. And one of the things they're thinking of the boreal system is that it's actually not, once it's a tree, that it's susceptible to that increased temperature. It's as a seedling. And so what's happening is those soils are warming up quicker, and other seedlings can outcompete those boreal system species. Because, of course, we know that people are growing eastern red cedar in their backyards here, but it's in those wild conditions where something is outcompeting it. That's really the concern. And so again, that one might be one that's, you know, going to be better adapted to northern parts further north, but it might not. all depends on, I think the bigger issue is going to be what happens with moisture for that species. And one, Peter Reich has an experiment looking at that, not specific to eastern white cedar, but to other boreal species, where he is warming the soil and seeing what the response of different species are to that warm soil, both temperate species and boreal species. So there is that is one of the only actual kind of on-the-ground research projects that I know of that's looking at climate change. Most of them are modeling ones. So did Paul have a question? It looked like Paul was typing, but maybe not.
As we're waiting, I want to thank you, Ann, for just an excellent presentation, and I wish that all our land managers in Minnesota could hear your presentation. It was really well done, and lots of fine information that you presented today. So thank you very much, and
well, thank you.
Success with your work and important work.
Yeah,
go ahead.
I was just going to say, the one thing I wanted to say was I think all of our land managers are thinking about these things and noticing these things, and I think that the piece of, what do we do as land managers to help us manage through this transition? I think, all the components of the state land managers are working on those things and thinking about that, and we're going to have to end up, communicating more and more. We already do, but communicating more and more and kind of feeding off what each other knows and has noticed.
Mm-hmm. I had mentioned to Ann before we started that about 4 years ago I was able to work with the Wisconsin DNR to establish the Cranky Lake State Natural Area on our farm just south of the Menominee Indian Reservation. We have a tour of the reservation coming up in May of the forests of the Menominee Forest. And we're also heading up to the Sylvania Track wilderness area. And we're looking at Hans Schavel's restoration forest, who was a retired professor at Stevens Point and one of my graduate professors. We also have a program coming up, early successional habitat management for birds of the Minnesota forested region, Friday, June 10th at the Deep Portage Learning Center in Hackensack, Minnesota. Jody Provost with the DNR has helped to put that program together. We're looking at yellow-winged warblers, woodcock, sharp-tailed grouse, and ruffed grouse. So this is the third time we've offered this program, and it's really well done. So we're looking forward to seeing those of you online again in the future. Feel free to let me know if you have other program needs or wishes that you'd like us to help host. Otherwise, we'll one more reminder, Ann's program today is going to be on the SFEC website as a link. So if you wanted to go back or refer it to other people, they can see it again. So thanks again, Ann, for your fine presentation, and wish you well with your work. And everyone have a happy day and a good spring. So talk to you later.
Thanks, everyone. Bye.